nitrogen compound, okay, you have been introduced to nitrogen compounds. Yeah, the main hero over here, yeah, the main hero of the main characters in this chapter, okay, will be amine. Okay, we have already learned all this. Okay, what is amine? Okay, amine is anything that has R and H2. Okay, amide is going to be anything that has R, C double bond O, and H2. Okay, and do remember, doesn't matter whether they have substituted. Like for example, if you have R and then N, then you have CH3 and then you have H. Okay, the H, one of the H is substituted. Okay, this is still considered to be amine. Okay, still considered to be amine. Okay, but they are called substituted amine. So if you have R, okay, if you have R, C double bond O, okay, you have N. This one is CH3 and this one is CH3. Okay, not H2. Yeah. Still, this is also called as amine, but they are called as Still, they are called amide, but they are called substituted amide. Okay, I want you to understand that. So, what is the big deal? What is the indication over here? The indication over here is, okay, as long you have N, okay, as long you have N, that is amine. Okay, as long you have this, is going to be amide. Okay, that is going to be amide. So I want you to understand that. And of course, okay, we have some another character which we will actually discuss later. Yeah, nitrogen compounds. You cannot talk about nitrogen compounds if we are not talking about amino acids. Yeah, so that one later. Yeah. So now let's actually talk about amine. Okay, amine. So we have different classes of amine. The common is this one, like just now when I mentioned R. This is the R group, and then you have NH2. Yeah. So this is going to be known as one R group, like something you learn in your alcohol. If you have the one R group attached to the N, they are called primary amine. Okay, primary amine. Okay, so let me check. Okay, Josh, primary amine or not?
Yeah, it's primary.
Yes, this is primary amine. Yeah. This one, Jordan, primary amine or not?
Primary?
Yes, primary. Okay, you see one R group. Yeah, but the name, yeah, will follow the R group. You see methyl amine. Okay, methyl amine. Ethyl amine because C2H5, ethyl amine. This is C3H7. Yeah, so propyl amine. Yeah, propyl amine. So these are the three primary amines. Yeah, three primary amines. So that is primary. Okay, primary means there is only one R group. Now we do have secondary amine. Let's look over here. Okay, you can see this is going to be one R group and another R group, automatically two R groups. Okay, so this is going to be a secondary amine. Okay, what is the name? You see, this is a methyl group. This is another methyl group. So dimethyl amine. Okay, it's a dimethyl amine. And you can have a tertiary amine. You see, one R group, two R group, three R group. Methyl, 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 trimethyl amine, and it's going to be a tertiary amine. Yeah. So Dylan, what is this? Okay, hold on. Let me draw. Okay, Dylan, what kind of amine is this?
Secondary.
Okay, secondary. Why? Okay, because one R group, another R group. Yeah, you do not need to know the name. Yeah, you do not need to know the name, but okay, we know that one of it is going to be ethyl. This is going to be propyl. Okay, so if you follow the alphabetical order, so it's supposed to be ethyl, propyl, amide. Okay, so if you want, okay, you can actually learn about the naming, but it's not necessary, but it's secondary. Okay, so please take note. Okay, I already introduced to you earlier. Amine, okay, it doesn't matter. Okay, you must not actually think that amine means must always have NH2. No. Okay, if you have one N, okay, one R, another H, still amine. Okay, if you have N, R, R, still amine. Yeah, still amine. So do remember that. Okay, but is this an amine? Erlin?
No.
This one is a bit different. Yeah, this one is ammonia, but it still behaves as an amine. Yeah, later I'll tell you. Yeah, this is definitely ammonia. Okay, this is ammonia. Okay, but we don't classify it as amine. Yeah, but okay, they do behave similar to amine. So whatever reaction that amine undergoes, okay, ammonia will undergo also. Yeah, they will also undergo the same reaction. Yeah, so this one quite difficult to say they are not. Yeah, but again, you don't classify them under primary, secondary, or tertiary. Yeah, you don't classify them. They are ammonia. Yeah, they are ammonia. They are different. Okay. Anyway, let's look at basicity. Yeah. So you see, that's why they have similar reaction. I mentioned that ammonia, okay, they will have similar reaction with amine. Both of them, okay, they will react as base. Okay, what is base? Okay, base is going to be a proton acceptor. Okay, base is going to be a proton acceptor. They like to accept proton. Why they like to accept proton? Because they have lone pair of electrons. Okay, so if they have lone pair of electrons, okay, so like ammonia, they have lone pair of electron. Amine, they have lone pair of electron. Okay, this one, okay, is a proton. H plus is a proton. Okay, why H plus is a proton? Okay, because hydrogen is going to be 1, 1. Okay, proton is going to be 1, electron is going to be 1, neutron is going to be 1 minus 1, 0. Yeah, so if I have H plus, okay, still 1, 1 plus, H plus means proton is 1, H plus means 1 electron is gone, so electron is going to be 0, neutron is 1 minus 1, 0. So H plus is actually a proton. One proton only. Okay. So H plus is a proton. Okay, is a proton. So this is going to be, okay, a proton. Okay, proton, they can accept, okay, they have this 1s orbital. Okay, they can accept the 2 electrons. So the electron, if I show you using curly arrow diagram, yeah, maybe like this. Yeah, they will donate the lone pair towards the H plus. Okay, not simply donate, they will form a coordinate dative bond. I hope you can remember your chapter 3 in AS. Okay, coordinate dative bond where they will give you the ammonium ion. Okay, the same thing, base also, amine also will do the same thing. Okay, same. Okay, ammonia. Okay, ammonia. Okay, they can react with acid. Okay, HCl, because there is a proton over there, H plus from the Cl. Okay, so when they react, okay, they will actually have the ammonium ion with the Cl. So you get this. So similar reaction. Okay, if you have a proton and this, of course, the same thing will happen. Okay, This one, okay, will give you this CH3NH3 plus and then Cl. So do you need to know the names? Okay, no need. Okay, but I think everyone should know this one, ammonium chloride. So what is this? This is methyl ammonium chloride. Okay, I think if you want to learn also, no problem. Yeah. Now, so you see the reaction, okay, they react as base, okay. Here I put as primary amine, yeah, because I think ammonia, they behave like similar like a primary ammonia amine, okay, or the reaction. I think this is going to be, I'm just showing the reaction for primary amine. Yeah, I'm not sure why I put it over here, okay. But basically, if it is going to be a primary amine, yeah, they can react with the H plus. Okay, or maybe I just want you to write the equation for primary amine. Yeah, correct. Okay, so what I wanted to mention over here is, okay, if you have a primary amine, okay, write the equation. Yeah, so let's actually see a primary amine. Okay, if I select one primary amine, maybe CH3 and H2. This is a primary amine. Okay, and then I am going to react with HCl, for example. What will happen? Okay, I will have this lone pair go over there. I will have CH3 and H3. This is called methyl ammonium, and then you have Cl. Okay, methyl ammonium chloride. If you want to remember the name, okay, but don't need, no need. Yeah. So this one already done. Okay. So ammonia and amines have different strength of bases. Yeah. So when we say strength of base, okay, it means we are still talking about base means ability to to accept proton. Yeah, ability to accept proton. Now, this ability to accept proton depends on the ability to donate the lone pair. Yeah, to donate the lone pair of electron. Now, if you are able to donate the lone pair of electron to the proton easily, then you are going to become a better base. Yeah. But if you have difficulty in donating the electron to the proton, the lone pair to the proton, then we say a weak base. Yeah. So we know that, okay, we know that all these ammonia is a weak base. Yeah, ammonia is a weak base and so on. So we want to actually check, okay, whether this ammonia, different types of amine, which one is going to be a stronger base. Yeah, so if you look over here, they say that, okay, ammonia is in the middle. Okay, ammonia is in the middle. And then you have phenylamine. What is phenylamine? This is going to be phenylamine. NH2. And then ethylamine. Okay, C2H5 and H2. They say that, okay, they say that ethylamine, okay, ethylamine, let's actually forget about ammonia first. They say that ethylamine is going to be a strongest base, okay, compared to phenylamine. And I just told you that it's all depends on the ability to donate the lone pair, yeah, of electron. Can someone explain about this? Okay, so maybe can we have someone to try over here to explain? Angela, you want to explain why? Okay, why maybe ethylamine is stronger base compared to ammonia or phenylamine? When we say stronger base, it means ability to donate the electron is more. But now my question is, yeah, why there is a better ability to donate the electron? Angela, you want to try? Or can we have Michelle to try?
Does it have something to do with how ethylamine has C2H5, which is an electron donating group?
Yeah.
And move on to phenylamine, I don't know,
Yes,
double
yes.
pi character. So
That's correct. Okay, it's correct. You see, just now I mentioned that, okay, ability to donate the lone pair. Yeah. And we know that C2H5, they are going to be electron donating group. It's electron donating group. So they will actually bring all the electrons towards the nitrogen. Yeah. When the electron comes to the nitrogen, okay, electron and electron, they like to repel or attract. Dylan. Electron and electron.
The one before that.
Repel or attract?
Repel.
Repel. Okay, if I give you electron over here, okay, what will happen? Okay, the electron will repel this particular electron over here. They will repel. Okay, they will repel this electron. So if they repel this electron, this particular lone pair of electron is more available for bonding or with the proton. Okay, more available for bonding with the proton. So that will make the any kind of methyl amine or ethyl amine to become a better base. Yeah, but if you compare this with a phenyl amine, this one is like what we have discussed earlier. Okay, what will happen over here? Same explanation. I think sometimes things will become very boring because it's the same explanation. Why? The lone pair of the electron, okay, the lone pair of the electron at the nitrogen, okay, will be overlapping, okay, with the pi bonding system. Okay, it will be overlapping with the pi bonding system, okay, making the benzene ring to become more stable. So it means that, okay, it simply tells you that the electron went inside the ring. Yeah, the electron went inside the ring. So now, pour the H plus waiting outside, okay, whether they are going to receive the electron, the answer is going to be they are not going to be receiving the electrons easily. Yeah. Why? Because it is less available for bonding. Okay, less available for bonding. So that's why if you compare, okay, phenylamine is actually a weak base, okay, compared to ethylamine, and ammonia is still in the middle. Yeah, ammonia is still in the middle. But whatever it is, okay, all of them are considered to become weak bases. Yeah, weak bases. Okay, but the one that is going to be strongest base over here, okay, when we say strongest base, we have to be very careful, yeah, because we say sodium hydroxide is the strongest base or something like that. Okay, but okay, when we say here why ethylamine is the strongest base, we mean why it is going to be strongest base among ethylamine, ammonia, and phenylamine. Don't get this wrong. Yeah. So if you compare, okay, why? Okay, because okay, ethylamine, okay, they are going to actually the ethyl group is going to donate the electron. Yeah, electron donating. Okay, they are going to repel the electrons, so more available for bonding. So that one we have already answered. Okay, why ammonia is stronger base than phenylamine? Yeah, if they ask you why this one is stronger than phenylamine or why ethylamine is stronger than phenylamine, the answer is the p orbital of the phenylamine, okay, or the lone pair of electrons, okay, they overlap with the pi system. Okay, they overlap with the pi system. Okay, the lone pair get delocalized and make it less readily available to form the coordinate bonding with other proton. This one cannot happen. Therefore, okay, it is going to become weak base. Okay, so that is going to be what I want to teach today. Okay, the reactions we do it some other time. But if you want to name now, these are simple questions. Yeah, so you see 1, 2, 3, 4, 5. Okay, 5 is pent. Okay, so this is going to be pentylamine. And then here, okay, you see this is amine, okay, but it's substituted by C3H7, okay, C3H9, sorry, C3H9, C3H9, okay. So if you have C3H9, okay, H7, sorry, C3H7, Okay, we know that this is propyl, this is propyl, so it's going to be dipropyl amine. Okay, I know that I said that you do not need to know how to name, but these are the questions from your textbook. Yeah, so let's actually learn also. Yeah, so here, if you have something like this, okay, what does it mean? So C2H5 NH2, when they react with HCl, okay, they are going to give you C2H5 NH3Cl. Okay, so if I have ammonia with H plus, I react and call this NH4. Okay, so if it is HCl, so I will call ammonium chloride. The same thing, this is going to be ethyl amine. Okay, ethyl amine. So this is going to become ethyl ammonium chloride. Okay, ethyl ammonium chloride. And then predict whether diamine is stronger or weaker base than ethyl amine. Okay, this one you see here, diethyl and ethyl. So I know it's already time. Okay, but you see C2H5, C2H5. Okay, and then H, and then you have ethyl amine, one C2H5, H and H. Okay, let's see whether you can understand today's lesson. Okay, which one is more basic, Kiara? The one with two C2H5 or the one with only one C2H5? Okay, the one that has two C2H5 will become more basic. Why? It's an electron donating group. Electron donating group, they will repel this lone pair of electron more so that they are more available for coordinate bonding. Yeah. So it means that this is going to be a stronger base. Okay, so you can read. Yeah. So anyway, take a rest. Okay, 8:45 you have lesson for today. Okay, see you guys. Okay, bye.
Okay, thank you, sir. Bye, sir.
Sir,
Bye,
bye, sir.
Ken. Bye.